All right, welcome everybody back to the math dungeon. We're going to continue our talk about volume and specifically today talking about prisms, cubes, and rectangular prisms. So we're going to start with kind of one question all rolled into three different shapes and where it says, what is the greatest volume? So you've got three different shapes in front of you. We're going to start just by identifying what the shapes are. So we know this first one, since we have all three dimensions that are the same, we know that's going to be called a cube. And you've probably heard of this before. This is just a little bit of review. So the first one's a cube. Second one has three different dimensions, so we know that's going to be a rectangular prism. And then our last one we know is also going to be a rectangular prism because we have three different dimensions. So we can use that formula you learned in elementary school. So volume equals length times width times height. And so in the video you saw the length and the width, they said that's the area of the base, right? So you might see that referred to when we start getting into other shapes like a triangular prism, is they start talking about finding the area of the base and then multiplying it by the height. So we'll kind of incorporate that a little bit today too, so you get used to hearing it. So for our cube, when you go to plug in, it's not as hard to plug in because the length, width, and height are all the same because it's a cube. All the sides are squares. So we have 4 times 4 times 4. And so that's the same as 4 to the third power, right? So if you had your calculator, you could plug in 4 to the third. Since we don't have them, since we're home, we've got 16 times 4 and 16 times 4. If you're not sure, maybe you try it out on paper. 4, carry the 2. You'd end up with 64. And my units, since I have 3 dimensions, is going to be inches to the third because I multiplied 4 inches times 4 inches times 4 inches. So that's going to give me inches to the third. So again, remember your area of your base, the base of this square is a square that's 4 by 4, right? 4 by 4 is 16. So there's 16 cubic, or actually I should say 16 square units down here. And then there's 4 levels of it. So that would give us 64, 16 times 4. Now, this formula is much easier, so I don't know why you wouldn't want to use it's just length times width times height. It's one that you kind of remember. But if you think about it and you want to do the area of the base times the height, you're welcome to do that too. It'll give you the same answer. So maybe you're thinking, this cube might not have the same volume as the others, right? The numbers are kind of close, right? So let's take a look at our next one. My board kind of slid a little bit there. Let's see if I can get to stay there. There we go, a little better. So our next shape, I'm going to use the same formula. So volume is equal to length times width times height. And I'm going to plug them in knowing that this is my length, this is my width, and this is my height. And you might ask, well, what if I plug them in a different order? Well, remember, multiplication is commutative, so if you plug them in a different order, that would still be okay. So my length is 4, my width is 3, and my height is 5. When you multiply them, think about what numbers are compatible, right? So I'm thinking 5 times 4 gives me 20. 20 is a nice, easy number to multiply by. So 20 times 3 would give us 60. So this would be 60 inches to the third. So again, if you plug your numbers in a different order, that's okay. And then our last one, so if I'm comparing these two, so far A is a little bigger, right? Greatest volume. So I'm going to have my length, my width, and my height again. So I can think about my length and my width, remember, is the area of the base. So the base of this shape is a rectangle. So I'd have all my different square units down there. So my length would be 6, my width would be 2, and my height is 4. So again, you could use compatible numbers, or you can just go left to right. 6 times 2 is 12. 12 times 4 is, you said it, 48. That is correct. So I've got 3 different numbers here. The question that we started with is, what is the greatest volume? So in this case, we know that cube that's 4 by 4 by 4 is going to have a slightly bigger volume than some of the other shapes. All right, so that kind of recapped what you guys had on Thursday. So if you maybe missed the video or you had questions, hopefully this helps. We're going to look, since we have a little bit more time, at just one more question on volume. And it's a rectangular prism as well, but there's only one this time, don't worry. And it's talking about drawer space. So think about when you're putting all your clothes away. Do you ever wish that you had more drawer space? I know I do. Always. So this is a young man who has a drawer, and it's rectangular in shape, obviously, since that's the shape we're doing today. So it's a rectangular prism. And he's got 25 centimeters wide. So I'm going to say this is my width, so 25 centimeters. He's got a height of 35. So that's my height. And then he's got a length of 35. So these kind of look similar. And when I go to put the 35 there, I know 35 does not look like that. So obviously mine's not drawn to scale. So we'll still go with 35 centimeters for our length. In reality, if I was drawing to scale, I'd be a little more careful with it, but it's not, since we're in the basement in the math dungeon, okay, I'm not going to redraw it. And then it says that he has 3 of these drawers, okay, so he has 3 of them, and they want to know what's the total volume, not the greatest volume anymore. So we want to know what's just the total volume of the 3 drawers. So we know our formula is equal to length times width times height. And I know with a little bit of glare there, I apologize. We're going to plug in our length, which is 35, our width, which is 25, and our height, which is 35. So when I multiply those out, now I'm not going to make you multiply them out, that would just be awful. If you multiplied all those together, you get a pretty big number. You get 30,625, and that's centimeters to the third. Now, I could say I'm done. That's the volume of this one drawer. But remember when I was kind of talking, I said there's 3 of these drawers, and we want to find the total volume. So I can't stop here. If I stopped here, I'd get partial credit, right? I knew to find the volume. I'd use the formula. I plugged in the numbers correctly. I labeled correctly. But what do we have to do with this number if I have 3 of these drawers? If you said multiply by 3, you are correct. We want to multiply that by 3, and we end up with 91,875 centimeters to the third. So it was one extra step there. So that's just an example of like a multi-step volume problem where you're starting with a shape, you have to find the volume, and then there's one additional step. You might see some like that in the future, not today. So today, after you watch this video, obviously we're done now after 7 minutes, your next task is going to be to go on and try Quizlet. So I did upload a Quizlet. It's real short. Just maybe try like the matching function, or if you want to do the test one, it's all just, here's a shape, can you find the volume of it? Try the, let's see, what other one did I do for practice? Oh, Khan Academy. So Khan Academy has like 8 questions you can go in and try. And then the last one that's for a grade is the quizzes. So Quizlet and Khan Academy is practice. Just, I'm not taking a grade for those. I want you to get in and do whatever practice you need so that when you do the quizzes, you are going to get 100 on it. Okay, because we don't have many grades left for this quarter. We're kind of winding down. The next shape we're going to get into is triangular prisms. So make sure you get mastery of this one before we move on to the next. So I hope you all had a great Memorial Day weekend and you're back at work. Good to see you guys.